sorry. All right. Yeah. So yeah, my name is Alberto, and today I'll be talking about Moonbeam, and more specifically, native interoperability on Moonbeam through XCM. So if you don't know, XCM is this like technology that allows different blockchains in the Polkadot ecosystem to talk with each other, right? So that's the fairly cool part about Polkadot. Like I said before, I'm Alberto, and I work at Developer Relations. If you have any questions at any point, let me know. So yeah, raise your hand, and I'm happy to answer any questions. So today we're going to do sort of like a little bit of a presentation about the project, and then do the demo itself. It's going to be like half and half. But the idea is to give you sort of an overview of Polkadot, Moonbeam, and then interoperability. And so we're going to do a little introduction about Polkadot, what it is, because a lot of people still don't know what Polkadot is. Then we're going to talk about Moonbeam, what is it specifically and why is it special. And last but not least, we're going to talk about interoperability, what Moonbeam offers, and a little workshop to show you guys what are we working on. I do really like this Doge meme because it's like Doge is, everyone loves the Doge, and it just basically shows you what Moonbeam is all about, right? It's about bringing Ethereum developers closer to the Polkadot ecosystem, basically. So Polkadot in 1 minute. You're not going to be an expert about Polkadot after this 1 minute slide, but the idea is to give a little bit of context on what Polkadot is and what the promise of Polkadot is, basically. So the main idea about Polkadot is a specialization, right? It's that there's no one blockchain to rule them all. There are many best blockchains in the space, and Polkadot will connect these blockchains and will secure them. All right. So Polkadot provides finality to the blocks, which is really important, and make sure that all the blockchains that are connected to this sort of hub or like this sort of mothership are secured and interconnected. That's the main idea. And so usually people in the space refer to Polkadot as a relay chain, or some other people layer 0. So layer 1, layer 2, then you have layer 0, which is above layer 1s. And so the parachains are these blockchains that connect to Polkadot, right? And they provide specific functionalities to the ecosystem. So instead of you having sort of like a chain that tries to be good at everything, you have specific chains for example, privacy, specific chains that are all like tuned in for storage. You have identity, Oracle, bridges, DeFi. So you have all the participants that together bring sort of like a broader ecosystem that provides functionalities to everyone. And then one of these parachains is Moonbeam, and I'll explain it in the next slide. So the important thing, once again, is that you cannot really build stuff on Polkadot. If you've ever used Polkadot, you cannot really build on top of it. You can just stake and do governance, right? So the idea is that Polkadot, it's a specialized chain to connect and secure these other specialized blockchains, but the application layers will live actually in these parachains. And that's one of the biggest difference compared to other blockchains. And the third thing that is really important is that Polkadot allows these participants to communicate with each other in a native way, which is very different than what bridges allows you to do right now, right? When you communicate through bridges, you have this middleman, this like entity, group of people, relayers, or whatever you want to call them, that you actually rely on them and to communicate with other blockchains, right? And we've all seen what happened with bridges. We have the wormhole hack, we have the Ronin hack, and so you have this trusted entity in the middle that sort of you're trusting it. With XCM, the difference here is that you already trust the Polkadot security model because Polkadot is finalizing your blocks. It has a sort of like an economic model to slash validators and everything. So you can trust that at least the messages that you're passing are going to be relayed correctly. There's not going to be any middleman that you need to rely on. And so one really important thing to understand about Polkadot is that Polkadot is nothing without the parachains, but the parachains are nothing without Polkadot. It's a two-way relationship. Polkadot is not the almighty God. You need parachains to provide sort of like a fruitful ecosystem. And the other thing is that Polkadot, it's all about interoperability. If we don't have XCM, there's nothing really special about Polkadot. It's just another blockchain, blah, 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 nothing great. With XCM, it's similar to Cosmos, right? But there's some differences there. With XCM, you have all these participants natively and in a decentralized, trustless way, the probably 3 favorite words about everyone in blockchain, communicate with each other, right? That's it. That's all I have to say about Polkadot. So what is Moonbeam, right? If you've never heard about Moonbeam, Moonbeam is one of these parachains, so one of these blockchains in the ecosystem, and we are specialized into providing a full Ethereum compatible environment on Polkadot. So if you've ever developed on Ethereum, you've used Hardhat, Truffle, Ethers, Web3 JavaScript, you can use all these tools on Moonbeam from day one, all right? And so, you know, the core layer of any Ethereum compatible chain is sort of the EVM, right? So you have the AVM, everyone knows the EVM. But then we also have sort of added layers or features on top of the EVM to provide extra functionalities. The first one is that we're built with Substrate. If you don't know what Substrate is, it's sort of an SDK to build blockchains. And the cool thing about Substrate is that it allows you to really easily connect to Polkadot for native interoperability, right? That's one of the things that we want. Next, we have the Web3 RPC support. And if you're a developer and you're familiar about what this means, it allows you to have all the Ethereum tools natively work on Moonbeam, right? So basically any tool like Metamask, Ethers, Hardhat, they all use the ETH-JSON RPC to communicate with an Ethereum node. And so we understand that language, and that's why all these tools work natively with Moonbeam. We also have unified accounts. If you're familiar with Polkadot, you know that you have the Polkadot.js extension that has a different account system. We forget about all that, and we use the Ethereum account system, right? So on Moonbeam, you will be doing staking, you'll be doing governance, you'll be doing Ethereum smart contracts interactions, all with your Ethereum accounts from Ledger, from Metamask, from Math Wallet, whatever wallet that you use on Ethereum, it should work on Moonbeam. And last but not least, we have really worked really hard into making sure that Moonbeam provides an Ethereum development-like experience with expanded functionalities. And I'll touch about the expanded functionalities in a bit. But we also want to be an interoperability hub, right? So like I said before, the idea of this image on the right is to show that we are more than just an EVM implementation. We have sort of these features that can differentiate Moonbeam inside the Polkadot ecosystem and hopefully outside of the Polkadot ecosystem as well. Yep. I think there's a mic because of this live stream. So yeah, sorry.
Can you just expand it just one sentence on the unified account? So is this Polkadot accounts and Ethereum accounts unified, or what's unified?
Yeah, so that's a good question, because if you are familiar with Polkadot, Polkadot uses an account system that it's based on SR25519 cryptography, right? So it's sort of like deriving from the mnemonic seed, deriving accounts in a different way than Ethereum, right? So you can still have the same mnemonic seed, but then you have Bitcoin accounts, Ethereum accounts, you'll have like sort of like Polkadot accounts. The problem is that if you want to have a full EVM compatibility, you have an issue, right? Because to interact with the EVM is using Ethereum style accounts, which use ECDSA, so elliptical curve, blah, blah, blah. And so the problem is that other parachain projects that have EVM, they sort of have to have Ethereum accounts and Polkadot accounts, right? And then if you want to do, for example, governance, because that is like a substrate feature, that is like a Polkadot native feature, but on this parachain, you have to have this like substrate account. So you have to use Polkadot.js extension, sign the governance transaction, and then all good. But if you want to interact with the EVM, you have to like send tokens from this account to the other account to be able to interact with the EVM. And for us, since we started Moonbeam, it's like, this doesn't make a lot of sense, because like if you want to provide sort of like a frictionless Ethereum environment, the first thing that you go when you go into this project is like, dude, how do I interact with the EVM, right? And so we basically modified the underlying code so that when you check who the signer is, you're using ECDSA cryptography, right? So in the world of Moonbeam, Polkadot style accounts have literally no meaning because all the signature checking, it's using the Ethereum sort of algorithm. So cool. All right, so like I mentioned before, the important thing about Moonbeam is also the on Ethereum, right? And one of the things that I like Ethereum the most is the composability, right? So the idea that you can, all these projects that are deployed on Ethereum can work with each other. You can interact with all of them in a single transaction atomically, in a centralized way on the blockchain, right? So they can, if they want, they can all work together in sort of like in this composable fashion without needing like permission, right? You cannot grab your like Instagram picture and then, well, you can because now it's from Facebook, but you know what I mean? It's like there are like this barrier sometimes in the Web 2 world that is not really true on the Web 3 world. And so one thing, if you think about it, is that you have limitless combinations, right? I really like Vitalik when he talks about DeFi. It's like he never expected sort of like what happened with Ethereum to happen. It's like, because there's so many combinations possible that it's not really like easy to see. And no one knows what's going to happen on Ethereum in 3 years, right? It's super difficult because of limitless combinations, basically. And so one of the things we notice is that to be able to replicate this on Moonbeam, one of the first things that developers asked for was tooling, right? Is that we need the tools to build on Moonbeam. And so that's why on Moonbeam, if you want the graph, you have the graph. If you want Covalent for indexing, you have Covalent. You have Chainlink, for example, for oracles. You have MetaMask, Ledger, and Trezor. Those wallets, which probably Ledger is the one that is more famous among these wallets, or MetaMask, you can use them on Moonbeam from day one. You have Etherscan, which is another dependency that developers were screaming for. It's like, we need an advanced block explorer. You have a Gnosis-safe multisig fork. So you have multi-sig wallets as secure as the true Gnosis multi-sig contracts. Pinata, Truffle, Hardhat, Remix, Ether.js. And for interoperability, we provide, that's why I put the Polkadot logo here, because this is XCM. But we also have good partnerships with Axelar and Nomad, just to make sure that you can also interoperate outside of the Polkadot ecosystem, right? And we're going to talk about this in a little bit further. So Moonbeam, right? So I like to say that Moonbeam provides interoperable composability powered by the XCM and the GMP protocols. GMP is General Message Passing Protocol, right? Because if you think about it, XCM, which is this Polkadot like sort of way that you can talk with each other, it's bounded to Polkadot only, right? And we want to make sure that Moonbeam is not only bounded to Polkadot, it's also be able to connect with AVAX, with Ethereum, and so that's why we're also like leaning quite a lot in GMP protocols like Axelar and Nomad. And GMP is General Message Passing, by the way. All right, so I talked about EVM with expanded features, and this is something that not a lot of developers know, and this is one of the features that I really like the most, because sometimes the EVM is quite limited, and we provide sort of extra functionalities. So what I meant is that we have some pre-compiled contracts, right? And the cool thing about the pre-compiled contracts is that it allows you to access sort of like substrate native features, so features that are not really inside of the EVM, from the Ethereum API, right? So one of the examples is the staking precompile, which allows you to do the staking, which is this, Moonbeam is a proof of stake network. You can actually, if you've ever used Moonbeam, and this is the dApp, you're actually doing staking, which is not an EVM feature, but you can see that you're signing the transaction with Metamask, right? So users don't really need to understand, oh, Jesus, this is a substrate feature, I should go to Polkadot.js apps. They just use Ethereum like they would in any other network, right? And so that's why you can actually stake with Ledger, with Trezor, and all this. Another precompile we can offer, and this is basically for developers. Developer can access the staking features from a Solidity interface. The same way with the Democracy precompile, they can access on-chain governance methods from a Solidity interface. And this allowed, for example, this app, which is called Polk Assembly, which is like a forum for governance decisions. They can actually vote on it using MetaMask once again. And this is a feature that is only available on Moonbeam because you have these sort of precompiled contracts. This is the one that is probably is the weirdest one, but it's one that makes a lot of sense, is that the Glimmer token, or the Mover token, which is the native token of Moonbeam and Moonriver, you can actually interact with it like an ERC20 token. What this means is that you can add, even though you have Glimmer in MetaMask as a native token, you can actually add it also as an ERC20 token. And so it looks weird because you have Glimmer here, but you also have sort of like the ERC20 version of Glimmer down there. And it's the same thing. It's not like we have like a wrapped version of Glimmer, which is what all the chains are doing, right? You have ETH, you have wrapped ETH. You have Matic, you have wrapped Matic, right? In here, it's the same token. Basically, you're accessing the substrate functions that allows you to transfer balance, but from the Ethereum API, right? So MetaMask will see the transfer function, so we'll just transfer this ERC20. This precompile, it's super exciting, and we launched it recently. And once again, like the idea for you to understand is that precompiles are extending the EVM functionality because that allows developers to access features that are not native from the EVM. And this is one that allows you to batch EVM calls into one single transaction. Right, so you can have the typical example I like to give is that we have sort of like a demo that I did the other day where you have, for example, a DEX. A DEX needs to ask you for approval to spend your ERC20s, and then you have to swap it. Right, it's a two-step process every time. If you go to any DEX, the first time that you interact with it, approve and then send. If they've implemented some EIP 712, you're actually signing a message and then swapping, but it's still a two-step action. With the batch precompile, what you can do is that you can batch the approve and the swap strinsics or transactions in one single Ethereum call. So the cool thing is that we expect, I don't know if you ever guys use Ocean Protocol, but I used it once and you have to sign like 6 transactions in order to do like a swap. It was super crazy. I mean, and I know this has a meaning, like you have to do 6 transactions because there's a purpose. But imagine you can just like batch them all into one single transaction. The UX will be 100 times better, right? And so this allows Ethereum developers to access this feature. And then we have a bunch more. If you participated in the Moonbeam River crowd loans, you actually claim the rewards using, once again, Metamask. So this was thanks to the crowd loan precompile. We have a call permit that is still being tested. This will allow any EVM action to be gasless, right? So this is a very interesting for projects like Biconomy. And then we have some more. If you're interested, we can go into more detail. All right. That's it. That's about Moonbeam. That's Polkadot. Let's talk about interoperability, which is the main topic of the workshop, right? And let's talk about XCM. So XCM, the way that I like to incorrectly explain it, because this is not correct, but it's like a good analogy, is that it's a format, right? It's a format of a message, right? So I like to say that in emails, right, you always say, hey, Alice, how you doing? The introduction. And then you have, how's it going? How was your vacation? You have sort of like a body, and then you have a goodbye sentence, right? XCM is similar like that. It has to have a very specific format with a set of instructions. And this is the most important thing. And this set of instructions, the combination of a series of instructions, is what you're actually going to result in an action, right? So basically the idea is that XCM is very general, very extensive, because it's not bounded by a bunch of rules. It's just a way that you have to write this message. And then there's a virtual machine. Once again, this is incorrect. It's not similar to the EVM, but you can think of it as an EVM that will actually interpret and execute these instructions that are given by the XCM, right? So let's say you have a message that is saying, hey, Alberto, walk 10 steps towards the door. The next instruction is flick the switch. And then the next instruction is walk back, right? This virtual machine, let's say it's my brain, is going to actually understand those instructions, and they're going to execute them, right? And so then you have the communication channels, what allows chains to actually talk with each other. And the channels are unidirectional, right? So let's say Moonbeam wants to talk with Akala, which is another parachain in the ecosystem. There has to be a channel from Moonbeam to Akala and a channel from Akala to Moonbeam, right? And any parachain that is already connected to Polkadot or Kusama, it already has a channel with it. You don't have to open a channel with the relay chain. And then there are different transport protocols, right? So the transport protocols is the way the messages are moved. So if it's from the parachain to Polkadot, then it's UMP. If it's from the Polkadot to Moonbeam, it's DMP. And between parachains, it's either XCMP or HRMP. It just depends right now on the technology. So the instructions, like I said before, it's what allows stuff to happen, right? So a combination, and you can find all the instructions in the top right corner. That's like a parity XCM sort of repo. And the combination of instructions, it's what allows you to do stuff in the other chain, right? So for example, these 3 instructions, what they do is that they withdraw assets from a special account in the target chain. Let's say I'm talking with Polkadot, right? So I'm telling Polkadot, hey, Polkadot, I want to remove X amount of tokens from a special account on Polkadot. With those tokens, I want to buy some execution time of your block, right? So the block has X amount of seconds, and then I want to buy 0.01 seconds to execute something. And I want you to execute this. So these are the 3 instructions that Polkadot will understand through their XCM VM, and will say, okay, so what you want me to do is to do a balance transfer, right? So these 3 instructions, for example, I quite commonly use to open communication channels or to remotely transact with other chains. And another important topic is weight. And this is not specific to XCM. This is the way you're familiar with gas on Ethereum. Everyone's familiar with gas on Ethereum. This is sort of the gas analogy thing of Polkadot and Substrate in general. It's called weight. And weight is defined as the time in picoseconds that transaction will take to execute, okay? And it's not the same if you execute it on an Intel Pentium from 2000 that you do it with the latest i7 machine. And so the idea is that Parity decides a standard hardware. So like i7 from 2020, this amount of RAM, this hard drive SSD with this specs, and then I'm going to see how much time my transaction takes in picoseconds to execute, all right? And so that's what you see on the right-hand side, different sort of XCM instructions, how long they take in sort of like picoseconds and how much they cost in dot, all right? The main difference here that you can notice right away is that, for example, this XCM instruction takes 1 billion weight units on Polkadot, but takes roughly like a tenth of that on Kusama, right? And this is because Parity has not actually measured the time that this instruction takes on Polkadot on time, but they did measure it on Kusama, right? So this is what it's called benchmarking. So they benchmark the amount of time that withdrawal asset takes on Kusama, but they've not done it on Polkadot, so they just say, okay, because we don't know, we're just gonna put a large number just to make sure that people cannot cheat the system, right? And so that's why you see a huge gap in sort of weight. The idea is that in the future, they will do it and they will put a more realistic number here. If you actually check, for example, how much time it takes to execute the buy execution, it's way less than the withdrawal asset. But on Polkadot, it's exactly the same, which is not really true. It's the same for Moonbeam, right? Using this instruction actually costs 200 million weights, but buy execution is the same because we have not benchmarked these instructions yet. What's important to understand then is that to execute these 3 instructions, we would need 3 billion weight units on Polkadot, quite a bit less on Kusama, and 600 million weight units on Moonbeam. So, but please understand that weight is not XCM specific. It's any transaction, even EVM transactions actually use weight. And what we do in Moonbeam is that we have sort of like a gas to weight mapping. We know that 12 million gas units, it's more or less this amount of weight because the EVM works with gas, but Substrate, the underlying technology, works with weight, okay? Cool. So this is the current status of XCM channels, right? So this is the communication channels that I spoke before. And what you can see is pretty cool because in Kusama, you have, I don't know, there's a lot, but there's all these parachains are talking with each other in once again, the best 3 words ever, natively, decentralized, and like in a native fashion, basically, right? They don't need to trust anyone. Trustless, decentralized, natively, right? I think, do we need the mic? All right, no worries. Yeah, go ahead. Yeah. All right, no worries. All right. So the question was, what was the legend on the lines? If some of them are dotted, I mean, the picture is not really great, but some of them are dotted and some of them are red. So the idea is that a channel has basically 3 steps, right? You need to propose it, and the other person needs to accept it. And the third step is to propose it back, and then so there's actually 4 steps, right? So I mean, let's focus, for example, on Pishu. You can see that there are 2 lines, right, and blue ones. That is because there's one line going to, for example, Karura, and another line coming back from Karura to Pishu. The red dotted lines is that they're proposals, right? So for example, Litmus, when I took this picture, Litmus actually proposed the channel to Moonriver, and we've not accepted it, and we've not proposed back. I think if you check this picture right now, we actually have the channel. But that is why there's differences, right? You can see that there are many chains actually communicating already on Moonriver. And then on Polkadot, we have a lot less chain because XCM is newer in Polkadot. It just launched like a couple months ago. I forgot to add something here that I found out the other day is that Kusama has a 7-day average of $100 million in value that is being transferred through XCM. And Polkadot has roughly $450 million in value transferred in 7 days, which is pretty crazy. And once again, this is natively, right? There's no relayers, nothing in the middle, like that it's assuring that you have these values somewhere else. All right, now we're gonna talk about XCM, but specific to Moonbeam. What is Moonbeam doing with XCM, right? And so the first thing that I'm gonna talk about the XCM use cases, because you have to understand what is Moonbeam using XCM for. The first one, once again, is token transfers. This is like, the typical like 101 because everyone wants to do token transfers. And so this is how token transfers works in general. This is not specific to Moonbeam, but the idea is that when you want to move dots, let's say, for example, to Moonbeam, what happens is that Moonbeam owns an account on Polkadot. And this account is not held by one person. It's like, I have the keys in my pocket. It's owned by the entire parachain. So the only way that the parachain can actually move funds out of this account is through governance, right? So it's not easy. It's not meant to be easy. The idea is that this account is very, very secured. It's not a smart contract. It's a native account that the parachain holds. And so the idea is that the first XCM instruction that is sent in this XCM message is this one right here that is basically say, okay, grab these tokens that you want to transfer and put them in this special account. And this XCM instruction actually has a field where you can put the other XCM instructions that you want to send with the message. And these XCM instructions are going to be sent to the destination account, okay, to the destination parachain. So it's like this XCM instruction has more XCM instructions that are going to be sent automatically to whatever account you're sending the tokens to. So if this is a Moonbeam special account, this message is going to be sent to Moonbeam. So that is why it's like atomic. It's not like, yeah, you can send these tokens to Akala, but the message is going to be sent to Moonbeam. It's all in one go. And so basically what's going to happen on Moonbeam is that you're going to have these instructions right here. And like I said, a combination of these instructions, what they do, let me finish and then I'll have you a question, all right? The combinations of these instructions, what they do is that, okay, I know that I got these instructions because I have this instruction right here. So I can check that I have the tokens in this special account. And this last instruction right here, what it's doing is that I'm going to actually mint a representation that we call XC20, which is like the representation of DOT on Moonbeam. And then I'm going to transfer it to a destination account that it was defined in the general XCM message. Okay? So there's a person with a question there.
Hello, hello. Oh, excellent. So if you're doing a transfer and bundle instructions so it's all executed atomically, if the instructions are unable to execute, does the transfer get reverted?
Yeah, that's a good question. Like one of the things about XCM that people need to be aware of is that it's not really atomic. What I meant atomic is that basically this instruction allows you to append more XCM instructions. But if the XCM message is not really well constructed, what's going to happen is that the tokens are going to get locked in sort of like a status that can be only withdrawn from a special like governance sort of proposal, right? So that is why developers always need to test XCM stuff on test sets and stuff, because if they don't really build the XCM messages correctly, it could fail. Depending on how you build it, it could fail on Polkadot, and that's going to be reverted fine. But if, for example, right, the message was fine here and it fails here, the tokens are going to be logged on Polkadot, right? So I mean, there's certain guarantees that you cannot be given because it's sort of like it's not an async sort of thing, right? I mean, it's not that, oh, I'm going to check to see if this works and then I'm going to do it here. It goes in one go, right? And this is the same with bridges at the end, right? You cannot really verify that the execution is going to work, even though you can estimate it and so on, but yeah. So the second use case, which is really cool because you're probably familiar with Lido, and this is what Lido is doing to provide sort of like liquid DOT staking and liquid KSM staking. It's called remote execution, right? And we provide, once again, a special precompile. So the precompiles, if you're not figuring it out by now, is that the way that we actually extend sort of like these Polkadot native features or substrate native features to the EVM. And so the idea is that you can trustfully execute on a remote chain. In this case, Lido is doing liquid DOT and KSM staking on Polkadot and Kusama. And so a user, it's interacting with their EVM wallet, right? So Metamask ledger. And what they do is that they sign a transaction with the Lido contracts. And so the Lido contracts give you the liquid staking version of the asset. In this case, is the STKSM, and they give it to the user. But the Lido contracts also interact with this special sort of like precompile instruction that is going to do a remote call on the Kusama chain. So this precompile will build an XCM message, and then we'll send it to Kusama, and we'll tell Kusama, hey, buddy, can you actually stake X amount of tokens, whatever tokens the user staked? Can you stake it to X, Y, Z validator on Kusama? But if you think about what's happening here, right? You have a user on Moonriver, right, directly staking tokens on Kusama, and once again, natively, decentralized, and trustlessly, right? This is true interoperability happening here, and this is how Lido is doing it. And so it's really cool to see. For me, honestly, this is the first true interoperable action, because remote transfers or token transfers are like boring at this stage, right? And so this is really cool because I don't know if any of you have staked tokens on Polkadot, but I mean, until 1 week ago when they launched a new interface, it was terrible. Like the user experience was terrible. And Lido, just like you go to Lido, you put, I want to stake 5, click stake, and that's it. Like everything is done for you. You don't have to worry about anything. And it's just how it's supposed to be, right? And we're going to see that, the idea of interoperability, 5 minutes? I have until 12:30. It was 12:25, yeah. All right, sorry, okay. Because I still have to do the workshop. So yeah, I mean, this is what true interoperability is, all right? And the last one we're working on right now is remote EVM calls. So this is a way that other parachains in the ecosystem can remotely call the EVM. This is very, very new. This is, it's super exciting, but there's still a lot of questions that need to be answered. But this is the way that we expect it in the future, right? So for example, other projects like Centrifuge, they want to call our EVM to do something, and they can do it via XCM. So I want to talk about XC20s because we're actually going to talk, we're going to use XC20s on Polkadot, on the demo. And so the idea of XC20s is that substrate assets are the ones that are interoperable, right? I mean, I cannot really send an ERC20 token that I have to any other parachain in the ecosystem. So the way that we actually did it on Moonbeam is that we have sort of like an ERC20 interface on top of the XC20s so that developers can actually access the XC20s through the regular tools. They can add, for example, dot as XC dot. They can add it to Metamask, and they can, do with like any other ERC20. You can transfer it. You can do whatever, right? So that is a cool thing about XC20s is that it allows these substrate assets that can move around. You can add it to any EVM dApp or anything because it's an ERC20 in the eyes of Moonbeam. It's an ERC20. So we have seen, for example, DEXs or lending protocols on Moonbeam, adding sort of XC dot to their lending pools or to their like farming pools and so on. And this is an example, and this we're gonna do it actually on the workshop. So this is a Moonbeam dApp, and if you can see here, there's a button called Add to MetaMask right behind basically the MetaMask, and this will add dot as XC dot to MetaMask as an ERC20 token. And this is the current status of XC20s on Moonriver. You can see that we have roughly 74,000 KSMs, almost 3.8 million remarks, which is a really cool NFT project. And we have more. And in Polkadot, we have a little bit less assets because it's newer. But one really cool thing is that we surpassed 1 million dots as XC20s, I think last week or so. So it's pretty exciting to see how these tokens have moved throughout the ecosystem. And this is the last slide before we go into the main part of the demo is connected contracts. So the idea of connected contracts is that we want to make Moonbeam sort of like an interoperability hub, right? I think we're positioned in a very nice way so that we can use the specialized chains inside Polkadot to talk with each other. But you can also have sort of GMP protocols like Axelar and Nomad communicating Moonbeam to other chains in the ecosystem like Ethereum, Cosmos, and Avalanche, right? And so the idea is that developers have to work really hard in making sure that these sort of like interoperability stuff are hidden from the user, right? Remember the Lido example that I gave before. In Lido, the user has no clue that he's from Moonriver doing an XCM message to Kusama or to Polkadot, right? So this is what we see the future moving towards to. We have a really cool project called Prime Protocol, and they're sort of like a maker. They want to do sort of like a stable coin that's over collateralized. But the deployment that they're going to do is that they're going to deploy everything to Moonbeam, but they're going to have sort of like smaller pieces of logic in each of these chains. And sort of like you can actually deposit sort of like AVAX in Avalanche to their protocol, and then mint the stable coin on Ethereum, right? And the whole logic is going to live on Moonbeam. So they're going to rely on interoperability protocols, but the cool part is that you actually have all the logic in one chain, and it's not like SushiSwap that they've deployed to 12 chains or something, and they have the same contracts on all the chains, and they have to maintain it. They have to have communities there. It's a lot more work, right? The idea here is that you have everything centralized, so it's easier to maintain. You don't have the liquidities as fragmented and so on. So this is the idea of smart contracts, that you have sort of like interoperability within Polkadot, but also outside of Polkadot. And Moonbeam has a special position there because it's very well positioned for EVM projects and so on. So for the XCM demo, we have to understand some really important concepts that it's very specific to XCM. So that's why I wanted to bring them up. And the first one is multi-locations, right? Everything in XCM is done through multi-locations. And multi-locations are a way to represent something in the ecosystem, right? The important, this was actually, this idea was given to me by a colleague. It's like, you can think of it as folder paths in Linux, right? So let's say you're in the data folder and you want to go to the pictures folder, you can just go up and then go down to the pictures folder, right? So the idea is that you have an origin and you have a destination, right? And so in multi-locations, for example, are always expressed relative to an origin. And like I said before, can represent anything in the chain, and they're represented by two parameters, a parent and an interior. The parent is how many hops are you doing up? So how many levels are you moving to an upper folder? And the interior is in that specific folder that you are targeting, where are you going? Where are you heading to, okay? So let's do some examples so you get familiar with multi-locations. Let's say we're in Polkadot, and the way that Polkadot sees its own blockchain, so I'm in Polkadot and I want to see Polkadot, is by saying parents 0 because I'm not moving up, and interior here. So interior can have either here or x1, x2, which is how many fields you need to define where you're going. It'll make sense when we see some examples. So let's say I want to represent an account on Polkadot, right? So the parents will be 0 because I'm not moving up, and the interior will be x1 because I need only one field to define an account, and that field is account ID 32, which is basically the Polkadot account, okay? If I want to move to another parachain, let's say Akala, I'm doing, once again, parents 0 because I'm not moving up, I'm moving down. And in interior, I want to define a field called the parachain ID. These fields, it's not that I'm creating themselves. They're a list of fields that you can define. And in this case, the parachain ID is sort of like the chain ID. It's an ID that a parachain has that is unique in the network. If I want to define from Polkadot, I want to go to Alice on Akala, I have to use x2 because I need two fields to define Alice's account. One is which parachain am I looking for? And the other one is what is the actual account that I need to target, right? On Moonbeam, it's very similar, right? You have, for example, if you want to target the parachain, you can do parachain ID. And the main difference for Alice, which is another account, is that we use Ethereum-style accounts, right? This is not Polkadot accounts. This is Ethereum-style accounts. Let's say that from Polkadot, you want to target an asset that we have on Moonbeam, right? The idea is that that asset lives under a palette, which is specific sort of logic. Let's say it's like a smart contract, but not. And so basically you can say, okay, I want to target Moonbeam parachain ID. The following, let's say a smart contract, even though it's not a smart contract, but it's a palette, the following palette and the following asset, right? So you're targeting a token inside Moonbeam, inside Polkadot, right? So this is a 3-step process in this case, all right? If we're standing on Moonbeam, if we're standing in Moonbeam, now the story is a little bit different because if we want to target an account, we don't need to specify the parachain ID anymore. We're already there. So we just put the account. And the same for the asset, right? So it's the same as before, but we remove the parachain ID. But now if we're targeting Polkadot, the main difference here is that we're saying parents 1 because we're hopping to a higher level, right? We're in the subfolder, and we want to go to the mother folder, or the parent folder, right? So we have to go one step up. And then for Akala, it's sort of similar. The main difference here is that we need to make sure that we go through Polkadot, and that's why we have to put parents 1 in both of these cases, all right? So that's basically the main difference. All right. So for today's demo that is going to be somewhat brief, we're going to use the X token precompile. So the X token, it's a way that we can send tokens from Moonbeam to other parts of the ecosystem. And so the precompile basically has a structure, which is the multi-location, that hopefully it's a little bit clearer now what a multi-location is. And we have two functions, the transfer one and the transfer multi-asset. We're going to use the transfer one because it's a little bit easier, because we provide basically the XC20 token address. So it's like an ERC20 token address. We provide the amount. We're going to build a multi-location to specify a destination account. And we're going to provide the weight, which you more or less know, but we're going to put a very high number, just not too worried about the weight, okay? And so basically, this is the 3 steps that we're going to do. And let's talk about the multi-location, right? So the idea of the multi-location is that it has a uint to specify the parents. If we want to send XC dot to Polkadot, we're going one step up. So parents need to be 1, right? Because we're going to move from Moonbeam to the parent folder, which is Polkadot. And then the interior in Solidity is built in a very specific, with a very specific set of rules, let's say, all right? And these rules are all specified in our documentation because you have to, once you get familiar, it makes sense. But at the beginning, you're like, yeah, this doesn't make a lot of sense, right? So basically, the idea is that the interior is built with a bytes array, okay? And the size of the bytes array determines whether it's here, x1, x2, x3, x4, all right? So if the bytes array is empty, we're saying that we're calling it here. If the bytes array is size 1, it's x1. If it's size 2, it's x2, okay? So this is basically a definition here that we see in the table. And then the first byte, or the first 2 hexadecimal characters, define what of these selectors are we actually selecting, right? So if the first byte is 00, we're actually doing a parachain ID. We're targeting a parachain ID. If we actually are 01, we're targeting a Polkadot style account, okay? If we're doing 02, it's that account index, and 03 is Moonbeam style accounts, all right? So if you think about it, if we're transferring XC dot to a Polkadot account, the way that the bytes interior will look like, it's 0x01, because we're targeting a Polkadot style account. Now the account number in hexadecimal is not the encoded value. And then this is a rule that you just have to trust me, and that you have to put 00 at the end. And it's because we want to say that this is like any type of account. It's not a Polkadot type account. It's not a Kusama account. We just prefer to put any because it'll be more generic and more, compatible with all type of accounts. All right. Cool. So for this like little demo that I'm gonna do, I still have sort of like 10 minutes, so that should be fine. You actually have to go to the dev token. So this is a faucet that we have for dev tokens. Dev tokens is a testnet token that we provide. We're gonna swap. You can swap some tokens. We have a Uniswap v2 fork, so you can swap some dev tokens for XC Units. So XC Units is our dot. So we have Moonbase Alpha, which is our testnet, and we have like a Polkadot on Moonbase Alpha, which tokens are called units. All right. And this is the ERC20 token address of the XC unit. So this is like XC dot address. Okay. And then you can also click here if you want to go to like the Polkadot.js apps second explorer for our relay chain, for the relay chain of Moonbase Alpha. Some important stuff is sort of the links of interest. It's like how to connect Metamask, how to check Polkadot.js apps. So similar to this one, but for Moonbase Alpha and the relay chain, the X token Solidity interface if you want to interact with it. This is Etherscan on Moonbase Alpha, and Remix, Remix, right? And this, if I have time, I'll show you how to build an XCM message on the relay chain to transfer tokens from the relay chain back to Moonbase Alpha, all right? So let's try this. Okay, so the first step is that I have Metamask. You can see here Metamask. I'm connected to the testnet. As you can see here, Moonbase Alpha. Let me zoom in a little bit. All right. So you see that I'm connected to Moonbase Alpha. This is Alice. Alice has a bunch of dev tokens. And you can see that Alice has already 5 XC units. So this is dot. Basically, we have 5 dots on Moonbase Alpha. If I want to have dev, you go to the faucet where you put in your address here. Very simple. And then you click here, and then you get some dev tokens. If you need XC units, which once again is like the dot representation, you can go to this Uniswap v2 fork that we deployed for demo purposes. And you can select here XC units. And I want to swap 1 dev token, and I'm going to get 7.4 XC units. This is for demo purposes. I mean, you're not going to farm or anything here. No worries. And then the interesting part here is in Remix, right? So if you have any questions building the multi-location, let me know. But building the multi-location is probably the most challenging task when you're going to use the Solidity interface, all right? So what we're going to do is that we're going to transfer 1 XC unit. You can see here because we have, basically this has 12 decimals. So you can see here that I have 3, 3, 3, and 3. So this is 1 token with all the decimals, similar to Way and Ethereum, all right? The address of the token is this one, like I showed before. So I can actually go ahead and add this token to Metamask, which I already did. So that's why I have it here. This is the account that I'm going to transfer the tokens to. And this is the amount of weight that I'm going to use for this transaction, all right? So if I want to build a multi-location, remember that the multi-location is a structure, and the first element is the parents, right? So if I'm going from Moonbase Alpha to Polkadot, I have to provide parents being 1 because we're moving 1 level up, right? So the first element of a multi-location, hopefully, I think you can see it enough, right? So the first element of my multi-location is going to be 1. It's very, very simple. And then remember that the second element was the bytes interior, right? The bytes interior. And if you remember the table, the size of the bytes interior will tell you if it's x1, x2, x3. So in our case, we need to, if we go back to the presentation, right, and we go back to this slide, you can remember that we are in Moonbeam. Oh wait, let me actually put it in presentation mode because it's a little bit small. So you can see here, if you remember, we are in Moonbeam. Well, actually, it's the next slide. All right, we are in Moonbeam, right? And we want to target an account. We want to target Bob on the relay chain. So we need to provide parents 1, interior x1, and the account of Bob, right? And if you remember in the next sample that I provided, basically here you have to say, okay, so I need to have an interior of 1, so it's going to be 1, and then it's going to be basically 0x01 to define basically that we're targeting Bob's address, and then 00 at the end, okay? So how this is going to look like on Remix, even though, like I said, this is just a rule basically that you have to follow. It's 0x01. Then we're going to put Bob's address. This is one-handed, so I'm going to put Bob's address. And then 00, because of this rule that we're saying, okay, this account, Bob's address, it's an any type of account, all right? It's not Polkadot, it's not Moonbeam, it's not Kusama. It should work with a Polkadot type account, but we prefer to make it extensible and generic, all right? So this is basically the multi-location. This should work, right? I mean, but if we want to, for example, test it out, we can just grab the the X tokens address, which is this one right here. Go to this tab in Remix. If you're not familiar with Remix, let me know, but we can just click here, injected Web3. What this is going to do is that it's going to connect Remix to Moonbase Alpha. This is the chain ID of Moonbase Alpha. And then we can just load the contract down here by pasting the address and clicking in Add Address, all right? So we have here the, it's probably, you can see it fine, hopefully. So we're going to use a transfer function. If you don't see this well, this is currency address. So the ERC20 token or the XC20 token that we want to transfer, the amount, the multi-location that we just built, and then the weight. Okay, this is the weight that we want to provide for this transfer. And what is going to happen if you think about it is that Moonbase Alpha or Moonbeam, let's talk about Moonbeam and Polkadot. Moonbeam has this XC dots, right? And what's going to happen is that it's going to burn this XC dots and it's going to transfer out of this special account that I mentioned, the dots back to the owner. And that is what we're going to see on the Explorer, all right? So let me fill this information up. So the address, this is the token address, the amount, the destination, which I hopefully did correctly, because if it's not, it's going to fail. This is the multi-location. And then the weight, oops. Yep. And then the weight, which I'm going to put here, 1 billion. Like I said, this is like a lot more weight. We're wasting money. It's like, you're putting more gas and so on, but this should work. So what I'm going to do is that I'm going to check this is the account that I have. This is the relay chain. So this is Polkadot. And let's say in Polkadot, I have 11.9 dot, right? And what's going to happen is that Alice, which has basically 5 dots, right? It's going to get deducted 1 dot, and that other account is going to get 1 more dot. And this is going to happen once again through XCM. I did something wrong, I think. What did I do wrong? 0, 1. Oh, wait, yeah. I need to put this in an array. Sorry. All right, cool. Boom. So now I have my MetaMask transaction. Once again, this is like a regular MetaMask interaction. And what's going to happen is that if we go to Polkadot.js app, so this is the Explorer of Polkadot, we can actually check that when this transaction gets processed, we're going to see an event. This is like a block explorer. We're going to see an event called assets burned. This means that the 5 XC dots are being burned because they no longer exist on Moonbeam. And then on Polkadot, or the relay chain, we're going to see sort of this thing being, okay, I'm going to deposit this 5 tokens to whatever person I specified. So you can see here, I got assets burned. This is the, well, sorry, it was 1, not 5. So I basically burned 1 token on Moonbase Alpha. And then on the relay chain, which is Polkadot in this case, I have the XCM message was executed successfully. So if I go into the XCM message, at some point, I'm going to have a balance deposit from the person to the account. You can see that I Alberto relay now got basically almost 1. It's not exactly 1, you can see, because I'm using that dot to pay for the fees, to pay for XCM execution fees on Polkadot, right? So that's why you're not getting return. If I go to the account, you can see that I have now 12.9 instead of 11.9, all right? And once again, this happened all natively. We executed that call on Moonbeam using Solidity basically as an interface because we're always targeting Ethereum developers for these sort of things, all right? I don't know if at this point anyone has any questions, any comments. Yeah, you sir. Want to pass the mic? Thank you.
Yes, so if I understand correctly, so you send native message from one parachain, for example, to the layer 0. Then layer 0 will interpret this message and translate it in order that he knows. Yeah. Then you see the result on the blockchain. And how, on your side, on Moonbeam, you know that it has been finally executed?
Yeah, that's a really great question. And the problem is that you just send the XCM message, right? But you don't really need, on Moonbeam, you don't really need to know or understand that the message was executed, right? Because once that block, the Moonbeam block, is finalized by the relay chain, that message was executed correctly or not, it was executed to your eyes, basically. What's going to happen if the message was not correctly built, right? It was incorrectly built, that message is going to fail on Polkadot. But that is basically the developer's fault, sort of like, you know, the message was not executed correctly, right? But from Moonbeam's side, from the parachain side, if the relay chain already finalized that block, Moonbeam can think that message was successful. So for a developer of a dApp, what they need to do now is that they need to understand that this is a multi-chain world, right? So they need to not only check the message on Moonbeam, they need to check it on Polkadot as well and ensure that message was correctly executed on Polkadot. And that's going to happen with any interoperable app, right? I mean, you cannot see blindly on Moonbeam and say, okay, this worked. You're going to have to see the action that you took on the destination chain. Was it successful or was not successful, right? So when you're talking about mono-chain deployments, it's a lot easier, right? A lot easier because if the smart contract interaction was successful, on Ethereum you wait 10 blocks and that's it, right? But in a multi-chain world, it's a lot more complicated because you have multiple chains in concatenating with it, I mean, talking to each other. And so you have to check finality on all the chains. So, all right, any other question? Cool, I mean, yeah, at this point, I think it just makes sense to stop here. Thanks a lot for attending. And yeah, I'll be around a little bit if you have any other questions. So thanks a lot.